All right, so let's say you're given this integral here, and the question asks you to compute the integral. To start, this integral above is a powers of sine and cosines integral. The general form of it follows this equation here. Strategy for computing this integral is identifying the components attached to each term. If m is odd, peel off one sign and convert the rest using this identity, sine squared equals 1 minus cos squared x. Then from there, use a u sub equal to cos x. Doing this, we'll take the integral with respect to x and write it with respect to u. Result should be an integral that's easier to compute. If n is odd, we peel off a cosine and convert the rest using cosine squared x equal to 1 minus sine squared x. And then we use a u sub equal to sine x. The last possible scenario is if both are even, we have to use half angle identities, which are given below. This could be better seen when applying to our example. The general form integral is given here. You can identify m is equal to 3. And 3 is an odd number. We can identify n is equal to 2, which is an even number. This is going to correspond to our scenario up here. We're going to have to peel off a sign, and we're going to have to use sine squared x is equal to 1 minus cos squared x to represent the rest of the integral in terms of cos. So we start off by peeling a sine x off. So this just means we write sine 3x as sine 2x times sine x. From here, we can convert the rest by using sine squared x equal to 1 minus cos squared x. So we can plug this in for our sine squared x term. Remembering we leave the sine x that we peeled off outside, we leave that one alone. So now we have everything mostly in terms of cos. Now this is where the u sub comes in, so we let u equal to cos x, and then du is going to be equal to negative sine x dx. So with our integral here, we have to write this whole integral in terms of u. So we define u as cos x. Cos squared x is going to be equal to u squared, and sub that in. We know that du is equal to negative sine x dx, so we can isolate for dx by multiplying both sides by negative sine x, and we get this here. So we can plug this in for dx, and when we do that, we can notice that the sine x that we peeled off actually cancels out. And so now we have a integral just in terms of u, which we need. Now we can just compute this integral directly using the power rule given here. If we isolate the term on the left, for example, the negative u squared du, n is going to be equal to 2. So we can plug in n equals 2 into the power rule equation. And if we evaluate it, we get this for the integral of that term. To split the integral into two terms, we can just distribute du into each term. Now we have two separate integrals, and we just solve for the integral on the left. And we can solve for the integral on the right using the same power rule, and we get this expression here. The answer for the integral, but we have to resub u in because our integral is in terms of x. U is equal to cos x, so we can plug that in for u. Get this here, and this is the final answer of the integral that we needed to solve for. It represents the integral of this equation here.